Hey guys! It's so weird. Okay, so I'm going to go over lesson 1 for Trig, and I'm going to do some examples with you, and we'll go from there. So lesson 1 is a complete geometry review, and I mean they cover like a million topics in one lesson. Some of this you might remember, some of this you might not. So this is going to be a longer lesson, and then there is so much in this lesson. I'm not really going to go over 1.A in your book. I don't really think it's that important, and you don't really see it, but it goes over the difference between a point, a line, and an array. Like I said, you probably know the difference, right? A point, a line is continuous, array has a dot on one of the ends, blah, blah, blah. Part 1.B is on planes. Again, I'm not really going to cover that. It's kind of self-explanatory in the book. 1.C goes over angles. And they go over all parts. And so I will spend a little time here just making sure we're all on the same page with angles. So let's first go over how we talk about an angle and how we label it. So if this angle was A, B, C, okay, I could name it several ways. So you need to be able, so when they refer to an angle, that you know what they're talking about. So I can either say that this is angle B, and that's how I would write it, or I can use all 3 points. So I could say angle ABC, or I could call it angle CBA. But notice what's important is that the B is in the middle when you're using all 3 letters. Okay, so that's how I know this is angle B, because B is in the middle. And I can zoom in. I want to make sure this translates well to the computer screen. And if I bring you closer, it's a little bit better. All right, another important thing to note is that B is also called the vertex. So our angles are named based on the letter that corresponds to the vertex. A couple other pieces of vocabulary you at least need to recognize. Angles can be formed 2 different ways. They can be formed counterclockwise or clockwise. Okay, so for example, if I were to measure this counterclockwise, it would only be, let's say, 30 degrees. But if I was to measure this clockwise, I went in a full circle and then some, so this would be 390 degrees. It'd be the 360 plus the 30, because I went in a full circle first. So just know there's 2 ways to form an angle. Counterclockwise and clockwise. It's super important for later. Also that these rays have a name. This side here is called the initial side, or think of it as your starting place. And this side here is your terminal side. Okay. This section, 1.C, goes over a lot of vocabulary. Things you should know are what is a straight angle, right? That's 180 degrees. What is a right angle? If you don't know that, I hurt you. Just kidding. But that's 90 degrees. What's an acute angle? Obtuse. Okay, it goes over a lot of vocabulary in this section. Acute, remember, is less than 90. Acute is greater than 90, and so forth. 2 things that are super important for the homework is the idea of supplementary and complementary. Now, this is all in the book, but I am going to do an example with you on how the homework is set up at least. So supplementary means that the angles add up to 180 degrees. Now, what's really important is you know how to write the supplement of, and to write that I would say 180 minus angle A. So that's super important. You're going to see that in our homework. It's 100 minus a because I know they have to add up to equal 180. So 180 minus the angle they're referring to would tell me what the other angle is. Complementary, I'm sure you remember this, is angles that add up to 90 degrees. Okay? But I would write the complement. Ooh, I feel like I'm spelling that wrong. Complement of is written 90 minus a. Okay. So in the next several sections, you're going to see homework problems that are talking about you solving for an angle based on whether it's supplementary or complementary. So we're going to try one. So 3 times the complement of angle A is 40 degrees more than the supplement of angle A. Find angle A. So, a lot of these that you will be seeing. So I'm going to go ahead and set this first one up with you. So this first says 3 times, so 3 parentheses, the complement of angle A. So complement is up here, would be 90 minus A is, okay, we use is an equal sign. And it says 40 more than. So it actually needs to be after. So the more than would be to write it after. And then it says the supplement of angle A. So I'm going to put that in parentheses. 180 minus A. Okay? So that's how this would be set up. This right here is the complement of, there's a tiny bug, of angle A. This right here would be the supplement of angle A. And if you want, like, maybe my notes are good enough for you and you don't need to watch the video, and that's fine. If my notes are not enough, then reference the video. You can pause a video, you can stop a video, right? You can fast forward through a video. That's the beauty of digital learning. So you use it to your advantage. So let's simplify. That would be 270, right? 3 times 90 minus 3 times A equals, you can drop the parentheses because there is nothing to distribute. So then I have 180 minus A plus 40. And I'm going to simplify from there. I'm going to combine 180 and 40. So that's 220 minus A is on this side. 270 minus 3A this side. Now, I usually don't review Algebra 1 steps, but I'm going to in the beginning of this class. So I'm going to add 3A. This is what I'm doing in my head. And so this zeroes out. And then I'm going to subtract 220. So that this zeroes out, and so I've got 50 equals 2A, so A equals 25 degrees, right? Because 50 divided by 2. Okay? So a lot of problems like that. Hopefully that helped you on how to set it up. Other types of examples that you might see having to do with the geometry is your straight angles. So if I had this here and they labeled this as x and x plus 40, okay, I know that these are supplementary. So x plus 40 must add up to equal 180, which would be 2x equals 140, so x equals 70 degrees. Okay? Should be pretty straightforward. Again, this is review, easy peasy, right? So if I have a straight angle, and they label this as 90, and y plus 30, okay? I know that this side must be 90, so y plus 30 equals 90, right? Because this right here is complementary. So 2y equals 60 means that y equals 30 degrees. So that should be all the review that you need there. 1 point D is going to be, they call it betweenness. And if you don't believe me, yes, that's what they titled it, and tick marks. So really the important thing I want to go over is the idea of tick marks. Tick marks are when you mark things with the exact number of tick marks. So these are these right here. And they mean that, so identical tick marks means that things are congruent. And congruent, they go over, is another word for equal. It's really all that's covering in that section. So tick marks are the same, mean that they are equal. 1 point E goes over all the types of triangles, and it's all review. I'm not really going to go over it. You can use the book. I don't really feel like I need to go over what an obtuse triangle is, but you have this section to reference it. But they go over what an equiangular triangle is, what a right triangle, what an obtuse. They go over isogenic, which is an isosceles, etc. So they go over all the different, whoops, this should be a C for etc. All the different types of triangles. You can use your book for that. I'm not going to go over that. 1.4, though, goes over a big topic in geometry called transversals of parallel lines. Okay, so if I have two lines cut by a transversal, I'm going to move this up. To indicate that it was parallel, right, I would do that. And this right here is your transversal. These right here are your parallel lines. In between my parallel lines is called the interior. Outside of that space is exterior. Okay? Now, why this is important is because it creates a ton of different kinds of angles that are congruent or supplementary. So, for example, if this was 130, then I know this is 130, which means this is 50, which means this is 50, which means this is 130, which means that's 130, which means this is 50, and this is 50. Now, this section goes over all the different types of angles. I'm going to go pretty quick. There is vertical angles, and that is when I have angles that are across from each other, and they are congruent. I have alternate interior angles, and those are also congruent. I have alternate exterior angles, which are also congruent. I have corresponding angles, which are also congruent. And last, I have consecutive interior angles, which are supplementary. I used up all my notes for that. So it goes over those types. and you can see it in the book. It's not really crazy important, but you will see references to it, so you do need to be able to do it. The last part of lesson 1, 2 more things I kind of have to go over, is 1.G, which is really important. It goes over the area and sectors of a circle. Now, I expect you to know the area of a triangle, so that I didn't really put in here, but I can go over it later. So if I have a circle, right, from here to here is called my radius. Area equals pi times r squared. Okay. Circumference equals either 2 different formulas. It's pi times the diameter or 2 pi times the radius. And the reason for that being is 2 radiuses equal a diameter. A sector is a section of the circle. Okay? For example, here's a circle. If I cut a slice of pi, that is a sector. Now, a couple of parts that we need to cover is the part formed here is called the arc. The angle here is called the central angle because it's at the center. And the formula for the area, so the area of a sector equals your angle, well, I should use equals your central angle divided by 360 times pi r squared. Okay? So central angle, they're going to use the letter C. They'll also use this in problems that are super complicated and we're looking for the area of a triangle and a sector and a circle. They'll put what part they'll label the area of what specific part by writing it next to the big letter A. Okay? So I am going to do an example with you here because you are going to see several of these. So number 1, if I have a circle, I know my circles are beautiful, and if I have the angle 126 degrees, and if I shade this region, if my radius equals 2 √5 meters, find the area of the shaded region. Okay? So here we go. First, the shaded region is represented here. So the shaded region would be the 360 degrees minus 126 degrees, which would give me 234 degrees. Okay? So the area of the sector, and I'm looking at the shaded sector, would equal 234 degrees over 360 times pi times 2 √5 squared. And then I'm going to start to simplify that. So here's how I did it, and you don't have to do it the same way, but they did want to find the area of the shaded region in terms of pi. You could also leave it in a decimal form. I'm going to do both ways. Okay? So here we go. If I simplify this, 234. I'm going to simplify this to be 117 over 180 times pi times 4 times √5. Okay? So remember, I'm doing 2 root 5 times 2 root 5, which equals 4 times 5, which equals 20. And so maybe I'll just simplify that in. And then I'm actually going to reduce this. So this gives me 1 over 9. So 117 divided by 9 pi equals 13 pi. Or if you do get a scientific calculator, your calculator has a pi button. So 1, 3, and then hit pi, and you get 40.84. So my answer is 13 pi meters squared, or 40.84 meters squared. And I'm going to put use pi button on calculator. So you'll have quite a few like that in your homework where you're looking for the area of a sector. Now that pretty much sums up this lesson. I do need to go over with you your textbook. On your homework, there are concept review problems. And they are always numbers 29 and 30. Okay? And to answer those, the answer is A if A is greater than B. The answer is B if B has an answer greater than A. And it is C if A is equal to B. Okay, so for example, if X is greater than 0 and Y is less than 0, compare A, X plus Y, and B, X minus Y. So for a problem like this, you would literally use some real numbers. So I would say, okay, let's say X equals 1 and Y equals negative 1. So part A, I would have 1 plus negative 1, which would equal 0. And B, that would be 1 minus negative 1, which equals 2. So B is greater than A, so the answer is B. Okay, so that is an example of those problems. It'll give you different ones to use and different examples, but you are evaluating them and finding out which one is greater or if they're equal. I'm going to assign you homework. For homework number 1, I'd like you to skip 15, 17, and 18. Okay. 18 looks a little funky. I apologize. But that is the end to this video.